Hello guys, Captain Pilot again, back with another video. Today we are going to be solving Cambridge International ASA Level S1 Paper 9709/5. This is variant 1 of S1 October November Series 2025. So let's begin. So the first question we have here is the random variable x takes the value of x with probability kx squared, where k is in constant and x takes the value -1, 1, 2, and 3 only. Drop the probability distribution table for x, giving the probabilities and numerical fractions. Alright, so let's draw a probability distribution table. So first of all, we're gonna write px because it's the probability x. Alright, and then this, now that this is p equals to x, now we're gonna write here x equals to r. Now px is gonna be -2, 1, 2, and 3. So if you substitute -2 instead of kx squared, what do we get? We get 4k. But we have to write this probability as a numerical fraction. So first, it's better off if we add all this up and find the value of k. All right. So how do you find the value of k? If we add all of these probabilities, we're supposed to get 1. So we can form an equation out of that. So k into -2 to the power 2, we get 4k. Then if we substitute 1, we get just k. Then we get 4k again because it's 2. And then we get 9k. And if we add all this up, we get 1. Now from this, what do we get? 4 plus 1 plus 4 plus 19 is 18k. So 18k equals to 1. Alright. So k is 1 by 18. Now that we know k is 1 by 18, we can just write down this value by substituting -2 again. But this time we know the value of k. So if we do that, we get, first one is 4 by 18. Second one we get is 1 by 18. Third one we get is also the same as -2, 4 by 18. Third one we get is 9 by 18. There we go. That's the answer, because we have to write it in numerical fractions, not decimals. That's why it has to be this. Also, just to check, you can just add all this up and it should be 1 as well. That's the best way to check probability distribution tables. Next one, find EX. EX is basically the multiplication of this with the addition of this. So basically you multiply this, -2 into 4 by 18, plus 1 into 1 by 18, which is just 1 by 18, plus 2 into 4 by 18, plus 3 into 9. No, wait. 3 into 9 by 18. This is EX. So what's the answer when you add all this up? You're supposed to get 14 by 9. Now you can write this as fraction, which is more safer. But if you can choose to write this as a decimal, and if you write this at decimal, you have to give it 3 sig fig. So it always has to be in 3 single figures. So you get 2.56 as decimal places. All right, great. Now it has given a probability. It says px is not equal to 2 given that x is greater than 0. Okay. So it has to be not equals to 2 given that x is greater than 0. So we have to first find the common in between this. So it has to be not equal to 0, and it also has to be greater than 2, which we can find from the probability distribution table right here. So not equals to 2, that means it can be -2, it can be 1, it can be 3. And greater than 0, that means it cannot be -2, it can be 1 or 3. So if we add these two, we get 10 by 18, because 1 by 19 plus 9 by 18 is 10 by 18. Okay, divided by x is greater than 0. Alright, given that x is greater than 0. This means given that, and given that it always have to be at the bottom. Only x is greater than 0. You don't have to include the first part anymore. So only x is greater than 0, that is -2 is not included, 1, 2, and 3 are included. So 1 by 18 plus 4 by 18 plus 9 by 18, we get 14 by 18. Now if we divide these two, we get 5 by 7, which is your answer. This is basically what I wrote here, is this. Px is not greater than or equals to 2 of this. Probability of x greater than 0. This is basically this. Alright. Moving on to the next question. If you have any queries on Or if you have any questions about these type of questions, just comment down below. I will be able to respond and help you out, hopefully. Next question, we have a fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 6 is obtained. Find the probability that a 6 is obtained for the first time on the 8th throw. So basically, a guy has a fair-sided dice with labeled 1, 2, 3, 4, 5, 6, and he's going to keep throwing that dice until he gets a 6. All right, so if he throws 1, for example, he gets 4, which is not 6. He throws again and again and again until he gets number 6. So we have to find a probability that 6 is obtained for the first time on the 8th throw. That means for at the 8th throw, he finally gets a 6, but before that, he doesn't get a 6. So basically, first time, the probability of this is basically for the first 7 times he doesn't get a 6. So what's the probability of not getting a 6? So we have 1, 2, 3, 4, 5. So the probability of getting a 6 is 1 by 6, obviously. So the probability of not getting a 6 is 1 minus 1 by 6, which is 5 by 6. So for the first 7 times, he does not get 5 by 6. So instead of writing 5 by 6, 5 by 6 into 5 by 6 into 5 by 6, we can just write 5 by 6 to the power of 7. That means for the first 7 tries, he does not get a 6. But then on the 8th try, he finally does get a 6. That's why you have to multiply that by 1 by 6. Because it says and. And means multiply and or means plus. All right. So if we multiply these, we are supposed to get this value. Decimal always, guys, always 3 sig fig. That's the answer. 3 sig figures, 4 6 pi figures. Now on B, it says find the probability that a 6 is obtained for the 3rd time on the 7th row. That means he gets 6 3 times. All right, he throws it 7 times, and he gets 6 3 times. All right. So the last time he got 3 was at the 7th throw. So one thing is for sure that he gets 6 3 times, right? It's gonna write probability. That doesn't mean probability. He gets 6 3 times. So there has to be 1 by 6 3 times. That means for the rest of the time, that means the rest 4 times he does not get a 6. Okay. Now the fun part about this is that this has a bit of permutation combination in it. So for example, these are the 7 rows. 1, 2, 3, 4, 5, 6. Sorry, 7 rows. 3, 4, 1, 2, 3, 4, 5, 6, 7 rows. So he gets a 6 on the 7th row, but we don't know when he gets 6 before. All right, it can be at any one of these. All right. So for this, there are how many ways can it be? There's 6 gaps. All right, that means it can be here or here or here or here or here. Okay, and there are two 1 by 6 left, since there are 2 times he does get a 6, but besides this. So that's why we write here 6C2, combination of all of this. All right, that's why we multiply this by 6C2, which we get is 0.0335. Answer. Also, this is very similar to binomial probabilities, right? Because look at the 6C2, 4, 3. So it's like it's like a mix of geometric and binomial, right? Except you have to figure out the last probability can be anywhere. So you have to use a bit of combination, which is why there's 6C2, right? So the next question we have is on a stem and leaf diagram. Stem and leaf diagram. So the 2 back-to-back stem and leaf diagram shows the annual salaries in dollars of 27 employees at each of the 2 companies, Browns and Greens. So the diagram is already given, drawn for us. The key is given, always read the key. That means always read the key. That means 327 means 32,600 for Browns and 32,700 for Greens. Find a median and interquartile range for the annual salaries for the employees at Brown. So how do you find mean? Median. So for median, the formula is n plus 1 by 2. And what is n? N is a total number. Total number here is 27 employees. So 27 by 2 plus 1, which we get is 14.5, so between 14 and 15. So from here, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it says for brown, sorry, my bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14 here. Let's see if this is actually the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yeah, this is the median. So we already have the median. Hence, the median. Since it's an odd number, we don't really have to do this. You can just do it manually or use common sense. So the median here is 324. That means $32,400. That's the median answer. Now I have to find IQR, which is interquartile range. Formula of IQR is upper quartile minus lower quartile. How can you find upper quartile and lower quartile? We already know the mean of this, so we can just separate these and these. Okay. So upper quartile is the median of this, and lower quartile is the median of this. So what's the upper quartile median of this? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median for this, we can quite literally find out that the median of this has to be, what can it be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6. So yeah, the lower quartile should be this, because the lower quartile should be this. As why? Because 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the lower quartile. And what's the upper quartile? The upper quartile should be this. Why is it this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So the upper quartile and lower quartile over here is 33500 minus 31300. Over here we get the value of $2200, which is the IQR. Okay, very simple. Now we have the annual salary of an employee at Browns is denoted by X thousands of dollars, and the annual salary of an employee at Greens is denoted by $Y,000. It is given that for 27 employees at each of the companies, summation of X is 878.3, summation of X squared is 28616.09, summation of Y is 296.5, and summation of Y squared is 29815.63. Find the mean and standard deviation for the annual salaries of the total for 54 employees. So finding mean is pretty simple. Mean is basically the summation of X plus the summation of Y divided by 54. Summation of X is given, summation of Y is also given, divided by 54, which we get as 32.867, but this is not the answer because it's $1,000. So in reality, this means that the answer should be 329. If you round this off as 9, that means it's gonna be like this. We always have to round it off to 3 sig fig. That's why this is the answer. Now we have to find the standard deviation. So how can we find the standard deviation of the total of this? So for the standard deviation, there's a formula. It's given in the MF19 sheet, which we can use. So the standard deviation total of this, right? Basically, you have to add this and this. If we add these two, what do we get? So summation of X squared plus summation of Y squared. If we add these two, we get, you guys can check my calculator. We get 58431.72 divided by 54. We have to divide it by 54 using the formula. That, and you have to subtract that from the square of the total mean that we found out over here, this part. Guys, also another thing to keep notice is that we have to do it again over here. You can just not just write this here because that's rounded off. That won't give you the correct answer. So just plus this, and we should get this divided by 54, and don't forget to square that. This will give you the right answer. Don't just use this. This will not give the right answer. You have to do it again. You have to find the mean again over here and square that. You have to use everything as exact as possible. Always give everything as exact as possible. We get 1, square root this, we get 1.36. And again, this is thousands of dollars. So we have to multiply this by 1,000, we get $1,360, which is the answer. Now we have a probability question. Bag A contains 8 red marbles and 3 blue marbles. If a marble is chosen is red, it is discarded. If the marble chosen is blue, it is placed in bag B. A marble is then chosen at random from bag B. If the marble chosen is red, it is discarded. If the marble chosen is blue, it is placed in block A. Basically the opposite of what this. So a marble is now chosen at random from bag A, right? Will be the tree diagram. So the first thing is given is 8 marbles, 8 by 11, 3 by 11. So if, oh well, so let me just write this RB, because there's only two like options. It can be either red or blue. So let's keep writing as this, red and blue. So for example, from back A you get red, and it says if the marble chosen is red is discarded. Okay, so that means the number of red will decrease. Number of red will decrease. In bag B, there are a total of 4 red marbles and 1 blue marble. That means there's total 5 numbers. So from red, 1 will be discarded, but over here nothing will change. So hence it's gonna be 4 by 5. So if this is 4 by 5, this is obviously 1 by 5. Now after that we go back to bag A. So since 1 is discarded, the total is gonna be 10, and now there's gonna be 7 remaining. So over here it's gonna be 3 by 10. Now from B, so you choose a red, and then from bag B you get a blue. So a blue is taken from bag B. It says here a marble is then chosen random from bag B. If it's chosen as red, it's discarded. The marble is chosen blue, it's bag A. Okay. So if it's red, it's gonna be discarded. If it's B, it's gonna be 1 by 5. Okay. So the total will be the same in red over here. It's just that the red will decrease by 1 since 1 is chosen here. But the total will still be the same because you're going to place one of the blues in the red in bag A. So total will still be 11. Over here it's going to be 7 by 3, and over here it's going to be 4 by 11. And in R, over here if it's blue, okay, so it says that chosen random from blue to marble is chosen red, it's discarded. So it's discarded. If this is discarded, it's going to be decreasing by 1, and it's going to be 10. And it's going to be placed back, which means the total number of R should be 4 plus 4, 8. 8. This is 8, it's going to be 2 by 10. And in R, it's going to be same as this, but since it's going to be discarded, it's going to be 3 by 11. Alright, very simple, guys. Very simple. Like, just read this and go through this. It's very simple. Pretty sure you guys can do it. You guys are smarter than me, so you guys can probably do it even faster than I could. So find the probability that all 3 marbles chosen at the rate are the same color. Now, this is where the tree diagram really helps, right? Since we don't have to visualize everything, the diagram is given as we'll follow the branches. So if all 3 are the same color, it can be red, 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 or can be blue, blue, blue. So if it's red, 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 that means 8 by 11 into 4 by 5 into 7 by 10. Or means plus, so it can be blue here, which is 3 by 11 3 by 11. It's supposed to be 3 by 11 into 2 by 6 into 3 by 11 once again. If you multiply all this, do it again. Let me just check real quick. We get 0.4316, so 0.4132, So we have to round it in three significant figures. Once again, next question we have is a probability again, but this time it's gonna be binomial with the looks of it, and we have a little bit of probability distribution over here as well. Okay, so how can we solve this? Well, let me just check. All right, so we have another probability question. So it says, on any given day, Cooper either wears a blue jumper, or he wears a green jumper, or he does not wear a jumper. The probability that he wears a blue jumper is 0.6, and the probability that he wears a green jumper is 0.3. Whether Cooper wears a jumper of either color or does not wear a jumper on any day, it is independent of the choice of the other. So it's basically just saying it's a binomial distribution question. Okay, so you know what? It's better to draw a small tree diagram, nothing too crazy. He wears a blue jumper, green jumper, or just walks around naked for all I care. Doesn't wear any jumper. So if he wears a blue jumper, it's 0.6. If he wears a green jumper, it's 0.3. And if he wears this, it's going to be 0.1, of course. So find a probability in a week of 7 days. So it's binomial. So n is 7 days. Wears a blue jumper. So the probability of blue jumper, so it's going to like this. Okay. But at least 5 days, which means at least 5 days. So it has to be, it can be 5 or more. So basically greater than or equals to 5. That means it can be 6 days or 7 days. Basically, it can be 5, 6, or 7. So I have to find all the probability of that. So basically, just use the normal gimmick of probability, which is NCR 7C 5 into the probability of this to the power 5 into 0.4 to the power 2 plus 7c6 into 0.6 to the power 6 to the power of 6 into 0.4 to the power of 1 plus 7c7 into 0.6 to the power of 7 into 0.4 to the power of 0. If you all add all this up, we get 0.420, which is the answer. Very simple as rice. I don't know why I said rice, but very simple as rice. All right, now we have approximation, which means we have to go to normal distribution. Use a suitable approximation. Just whenever you see this, means you have to convert from binomial to normal distribution. To find a probability that in any of 150-day period, Cooper does not wear a jumper on fewer than this. Okay, so for a normal distribution, we need two things. We need mu and we need sigma square. Mu means mean, and sigma square means variance. We don't really need variance, but we have to write it here. It's just kind of the rule. I don't know why it's Cambridge things. Anyways, so how can we find mu? The formula for mu is NP. Okay, so what is N? N is 150 over here given, and P. Okay, does not wear a jumper. So he basically doesn't wear anything, which is 0.1, as you can see over here. So this into 0.1, which we get is 15. And now sigma square is NPQ, which means N into probability of success into the probability of failure. So 150 into 0.1 into 0.9. Okay. We get 13.5, which is sigma square. So normal distribution is this 15 and 13.5. Okay. And it says px is fewer than 22. Now, since it's an approximation, we cannot just write it as this. We have to convert this, we have to approximate this, which we can write as px is less than 21.5. Whenever it says less than something, you have to subtract 0.5 from it. That's how I learned it, at least. So x is greater. So for example, if it was given px is greater than 22, we have to write it as px is greater than 22.5. Add 2 to it for that. But this is not always the case. For example, if it was given x is greater than equals to 22, then you have to write the opposite of that. All right. So now that we're given here, we have to use normal distribution. So PZ is greater than 21.5 minus 15. Now over here, I repeat, we have to use standard deviation, not this. This is the variance. So we have to square root this. 13.5. Okay. So now we have to simplify this. We get 1.769. Now we have to use the table and MF19, good old MF19. So values for this. We have all the list of the values here. From this, I'm pretty sure you guys can figure this out. If you have a scientific calculator, you can also use that to figure this out. Though Cambridge doesn't like students doing that, though if you can get away with it, then go ahead. Just to be safe, you can always use the good old, the time-consuming method, or you can just go with the calculator. It doesn't matter either way. You can just show the steps and you can fool the examiner. I don't care. So using this, get the value of the 0.962, which is the answer. Hooray! Easy 5 marks, right, guys? Right? Now we talk. Now we're at question number 6. A factory produces chocolate bars. Again, this is probably normal distribution, I can already tell. The weights of the bars are normally distributed. This just, like I said, guys, this literally means it's normal distribution. The mean is given and standard deviation is given. So again, write this. Mean is 155, and right, guys, you have to use variance, not standard deviation. Square this, 6 squared 36. Just write this over here, and the total random sample is given as 350. Okay. So it's between this. So we can write this as P. X is less than 160, but it's greater than 148. So these are questions. Again, not that hard, guys. I'll show you how it's done. Pretty simple. So 148 minus 155 divided by 6. Then 160 minus 155 by 6. It's better to draw a diagram always for these type of questions. So mu is 148. Over here is this 6. Between this and this is negative, as you guys can see, so it's gonna be 1 in here and 1 in here. Basically, you have to find this area, right? So if you solve this, simplify this further, we get a negative of 1.1667, greater than the z value. Okay. Get 0.8333. Okay. Now, since this is a negative over here, we need to do some stuff. Basically, since this is negative, you have to subtract this from 1. 667 minus 1 plus this 0.8333, and we subtract this from 1. Now use the, again, guys, use the sheet or calculator, whatever you guys want. Then we get 0.7975 plus 0.8764 minus 1. We do all the math, we get 0.675, which is the probability. But it says how many of these 350 bars. So if you multiply this by 350, that's basically the total number of bars which fits in this scenario, which probability by this 350, which we get is 236.6. But it says total number of these bars, and number of bars cannot be in decimal unless like you chew one bar and you I don't know, but you have to round this off. So either you can write 365, but normally over here it's 0.6, right? So you shouldn't round up, you should round down actually, because there is already 336 bars. Right, they're already done, and there's just 0.6 more. So you can just write this as 236. That's the best answer. 237 won't really work since you have to round down it, not round up. It has to be integer value. next question we have is again normal distribution. Wow, there's too many normal distributions. So second factory also produces chocolate bars. Great. I guess everyone loves chocolate. Wow. Me too, I guess. The weights of these bars are normally distributed with a mean of this u gram and standard deviation. So these are the variables given. Tests show that 8% of the bars weigh more than 115 and 20% of the weigh less. So it's basically like we have to form two equations, we have to simultaneously solve them. So what is given here? It's better to always draw a diagram as well. It helps with imagination and helps reduce errors. You show that 8%. Now 8% means 0.8 is the probability. So 0.8. If it's here, can this whole thing be 0.8? Yes. Alright. And it says 20%, 0.2. Okay. More than this. 0.8 is gonna be here. This part is 0.8. So we can write as this px way more than 114.0 grams is 0.8. And again, guys, a normal distribution over here. I don't know if you guys can see very clearly. Okay, if it focuses, then it will show. Unless it won't, I can't really show much. Basically, over here it's less. As you guys can see, it's less. It cannot be greater. So you can subtract this whole thing from 1. So what I'm trying to say is subtract from 0.81. That's gonna be this. Is 0.2. You subtracted 1 from here. Okay. It just makes things easier. Now we use the normal gimmick. Sigma. This is going to be 0.2. Now for this, I prefer to use a calculator as we have to inverse this now. If you guys want to know how we can do this with a calculator, comment down below. I can show again. But basically, guys, if you have this type of calculator, this model, you can just click on mode. Okay, click on mode, then click 7. All right. Now you can see I have these values. All right. Then click on inverse normal. Click 3. 3. Okay. I clicked 3. Now for area, just write 0.2 as that's what given here, and then just click equals to. That gives the right value. That gives the inverse of this basically, which is given as minus 0.8416. So we already have one equation, right, guys? So we have to find the next equation. Just do the same thing again. Okay. So px is less than 99.5, 0.2. For here, it's already given it less, so we don't have to subtract from 1. But it's gonna be a negative value, as you guys can see. It's smaller than the mean. No, it's not smaller than the mean, but actually it can be positive. Actually, we don't know since we don't know the value of mean. So let's just keep solving. So 99.5 minus mu by sigma. This is 0.2. Then inverse this using the trusty calculator. It's better to keep this, guys. Very helpful. It saves time, saves shit. Shit saves your grades actually. So we get minus 0.8. Wait, guys, wait a second. Huh. We keep getting the same thing. Interesting. Interesting discovery. Okay, these two values are exactly the same. I don't know what I did wrong here. Let me just see what's wrong. This, less. Okay. I think if we solve it anyways, we're supposed to get the right value. Wait, guys. I think I might have made a bit of a mistake. What is that? It says greater more. Huh. Okay. Okay, I see what I did wrong. Wait. Okay, guys. Very big error. I'm sorry. This is supposed to be such a dumb mistake. I hate myself. It is 0.08 because 8% is not 0.8. I don't know why I wrote this. This is going to be 0.02. Sorry, guys, 0.02, which means this part is not going to be this actually. It's going to be 1.406. My bad. Now we're good. We're totally fine. So now we solve this simultaneously, and we should get this. We should get sigma as this. Pretty sure you guys can solve simultaneously. I need to show with that. You have two equations, solve simultaneously, get this. Of course, do show that you're solving simultaneously. I did it because I'm just showing the steps because I don't have to show everything. But you make sure to show and get these easy 5 marks. Come on, man, guys. It's easy 5 marks. Come on. Now, oh, okay. Okay. I think I did a bit of a printing mistake here. Okay, I did a bit of a printing mistake here. This is the topic I hate with all my heart. Permutation combinations. It has given me headaches. It's given me heartbreaks. Yes, maths gives me heartbreaks, not breakups. Okay, so how many different arrangements are there? The 10 letters in a word. I don't even know what the hell this is. Sea chilies. I don't know what the hell this is. Anyways, so 10 letters. So first of all, there are 10 letters, so 10 possibilities. So easily 10 factorial. But you cannot include the repeated thing. So how many repeated alphabets are there? So as you guys can see, there's two S. That's why to divide it by 2 factorial. There is two L's. So again, 2 factorial. And there is three E's. 3 factorial. That's how you do it. And we get 1.1200. That's the answer. Great. Now, how many different arrangements are there of the 10 letters in the word this, in which there are exactly two letters between S's and one of the two letters is C? Okay. Okay. So 10 letters. 7, 8, 9, 10. So there are two gaps between two letters, and one of them is C. So, for example, if there's an S here, there's going to be an S here, and one of them is C. Okay, so how many gaps are there? 1, 2, 3, 4, 5, 6, 7. So, 7 letters, 7 ways, so 7 factorial. And over there, excluding the two S's, how many repeated stuff do we have? We have two L's, that's why 2 factorial, and we have 3 E's, that's why 3 factorial. Now, there is. Okay, now how else can we do this? Okay, there are this three number of ways. How many number of ways can we write this? 1, 2, 3, 4, 5, 6, 7, 7 factorial, and there are two S's. Now these two S's can be in different formats. So I have to do multiply by 2. As this S can be here, and then C can be here, just an S. So how many ways can we write this? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there can be an S here, okay, C here, S here, or there can be an S here, C here, S here, there can be an S here, C here, and S here. Yeah, there can be an S here, S here, S here, or S here, C here, S here, or there can be an S here, C here, S here. So how many ways can we write this? 1, 2, 3, 4, 5, 6, 7. That's why you multiply this by 7, as there's 7 ways we can do this. It's 1, 2, 3, 4, 5, 6, 7. Okay, so if we multiply all of this, we get 5880, which is your final answer. That is it. Okay, now we're at the final question. Yeah, it's final question of the paper. Well, the final 2 questions. Okay, now let's see how many different arrangements are there of the 10 letters this in which there is an S at the beginning, an S at the end, and the 3 E's are not next to each other. This is a pretty fun question, and honestly, it's pretty simple than it looks. So, again, write 10 gaps. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is an S at the beginning, and there's an S at the end. Okay. What else? There are 3 E's are not next to each other. So what I like to do here is I find a total number with E's together. So for example, 1E, 2E, and 3E. Okay. So whenever it says something is next to each other, okay, I will first find next to each other, then I'll subtract from total to find not next to each other. That's easier than this. That's how I like to do it, at least. So how can we find all of them together? So think of this as one possibility. All right, think of it as one possibility and then take it into account. So 1, 2, 3, 4, 5, 6. 6 ways. Right. 6 factorial. Okay, and of course there is a possibility of S's are not going to count. There is a possibility of 2 L's, that's why I repeat. So this is the together. E's together. Okay. Now, what about they are not together? They're not together, or I mean, if now just find the probability of just this whole thing without E's, just the number of ways it can totally go down. So, E's in here. Okay. Okay. So forget about the E's and forget about everything. There are 2 S's here, and how many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. But you have to recount the repeat alphabets. 2 factorial for 2 L's, 3 factorial for 3 E's. This is a total number of ways can be done, and this is with E's. So you subtract this 2, okay, in this condition, and we get the answer as 3000. Very simple. Okay. And do not subtract this from this. Okay, this is for 10 letters, no condition, but there is a condition here. There's an S and this. So with this condition, you find the total number of ways and then subtract it with this. Okay. Now, of course, you can do it directly. You can find not together, but I like to do this. It's safer, and for me, it's easier. You guys can try another way if you guys want. So 5 letters are selected at random from the 10 letters. It says selected here. So we will not use permutation in this question. We're going to use combination. So 5 letters are selected. 1, 2, 3, 4, 5. And the probability that these 5 letters include the 3 E's. So all 3 E's right here. Okay. Now, for these other questions, I like to write this down because you would need this. So all the 3 E's are already here. So we're going to cancel the 3 E's. We're not going to look at them. All the 3 E's are already here. So how many possibilities are still left? 1, 2, how many alphabets are still left? 1, 2, 3, 4, 5, 6, 7. So out of these 7 letters, only 2 of them can be fitted in here. That's why 7C2, which we get as 21. Now this includes the 3 E's. Okay. And now this says probability. So this divided by the total number of chances. So there are 10 letters, 5 can be here. So 10 C5 is the total number of ways it's going to be done. The total number of selections, actually. Selections, which we get as 252. So probability is this divided by this, which we get is 1 by 12, which is the answer. And there you have it, guys. The whole paper is solved. We did it in about an hour. We did it in exactly 45 minutes, actually. Wow, that is way earlier than it should. Very easy paper. You guys can probably do it. If you have any queries or any questions, make sure to comment down below. I'll sure to respond and help you with the best solutions I can. And until next time, make sure to subscribe, like, subscribe, share these videos to all of the people who need this, all of your friends, people that struggle with this paper or anything else. And keep tuned, turn on post notifications because I'm going to be uploading more past papers for physics as well if you guys want. And if you guys have any specific papers that you want me to solve, then comment down below. I will try to make as fast as possible. And until next time, catch you guys later.